Hello everyone, welcome to my short Kinect and PyAF demo. This demo or this application is a direct result from Rhys Kirk's blog post on Microsoft Kinect, and he stated that we should focus on being able to wave at Pi instead of all those cloud nonsense and mobile devices. So, well, he got me enthusiastic. I got out and bought a Kinect sensor, downloaded the new Kinect SDK, and just started programming away. And this is a short video on my progress so far, and I just wanted to show everyone what you can do with Kinect and how pretty easy it is. In this demo, I will explain some of the basics of this application, and we will have a short demo on how we can use Kinect to traverse to an AF tree and to create some trends. So at first, this application, you see me standing in this weird pose, but I will come to that later. On the left side of your screen, you will see a video of me. That's just an RGB video. The Kinect sensor has two cameras. One is just an RGB camera, so that's that stream, and the other one is a depth camera, and it uses a infrared transmitter and an infrared camera, and this way it can measure depth. So if you look at the middle image where you see me all in yellow, you can see that if I take, for instance, this chair, and at first it will register the chair as a part of me, but if I let it loose, you will see that it's just another object. And you will see if I move it to the front, you will see that it's light in this image. If I move it to the back, it gets darker. And that's just an image of the depth measurement. So it's a grayscale image in this case. But the Kinect sensor returns an image with all the depth information, and in this image I've transferred the depth information into grayscale video. And as you can see, if I touch a chair, the Kinect sensor will register the chair as a part of my body, but I can move it back, and then now it's gone. So now you see me in old yellow, and as you can see, if I walk to the camera and back, the yellow doesn't change, so that's always the same. And you can register up to 2 players in this way, and they're planning on having up to 6 players. So you can see if I move out of the frame like this and I come back, you will quickly see that it will register me as a player, as a person. And you can also see on the skeleton image on the right side that the Kinect sensor registers all the joints. So you can see my head in the above joint, and you can see my shoulders and of course my arms, and you can also see my legs, but these are out of the image for now. Alright, so the Kinect SDK that was released about a few days ago, it really helps a developer to interact with the Kinect sensor. So in this case, as you can see all the joints, and you can get information from the Kinect sensor where all the joints are. And with that information, you can build a skeleton in code, and well, you can attach all the joints. So in this case, I build a skeleton in code where, for instance, my middle part of my shoulder is connected to my head, or to the head, and to the middle part of the shoulder, the left and the right shoulder blades are connected, and my elbows and my wrists and my hands. So I put that in an image, and as you can see, if I move, the skeleton will move with me. And this has become a vital part of developing positions or gestures, because you can visualize what happens, and then in code you can program different gestures. So the Kinect SDK comes with a lot of options and a lot of possibilities, but one of the main things it doesn't do is recognize gestures. So that's something that a developer for now has to do on their own. And there are a lot of things you have to consider. In this short demo, I've been working on this application for maybe 10 hours or something. So it's pretty difficult to really register and to be able to teach gestures. But what I've done for now is just create positions. So in this case, I have a natural stance position. That means that my hands are above my hips in the 2D image, and they're below my shoulders. So this is for me a natural stance. If I, for instance, point my right finger on top, you will see that it registers as that my right hand is raised. If I put it back, it will go in a natural stance. Same for the left hand. And also, if I put my right hand down, you will see that it registers this as a lower right hand down position. So if I have a position, make a position and go back to my natural stance, I can register that as a movement or as a gesture. So it's pretty basic for now, and I hope I will be able to in the future, for instance, recognize how wave and how many times you wave, and for instance distinguish between a wave and this movement, which looks really funny on the skeleton. So yeah, as you can see, you can have different gestures or positions, and in code using the SDK you can recognize those. For instance, this is just a simple position, and I will just calculate when my hand is above my right hand is above my right shoulder, and then the position is I'm putting my right hand up. If I go back and put my left hand up, it will register that my left hand is above my left shoulder, and so on. For this demo, I've prepared a little AF tree that you can traverse using the Kinect SDK. So at this moment it's not accepting commands, but I've programmed it to start accepting commands when I put both my hands up. So let's do that. And as you can see, it's now accepting gestures as commands. So I will first go. You will see AF elements on the left side of the screen. If I want to traverse down, I will put my right hand down, and you will see it recognizes it as a traverse down command. So I can do that. Go back to my natural stance and use it like that. So we can go into this element, and there's a number on the right side that tells us how many child elements and attributes this element has. So if I point to the right, we will enter that element. Alright, and now I can traverse down or up using my hands, just my hands. Alright, and I can enter this element, and you will see it has elements and it has one attribute on top, on the bottom. So we can go to that. It works. We can go to that element, and I can give a command or point my fingers to the right, and it will make a trend of that attribute. So let's do that. It will take a little while. Yeah, alright. And I can go up again and traverse another element, and I can create trends from this attribute as well. If I go to the natural stance, I point to the right, and it will create a trend out of that. Same for this one. And I can go to the bottom one and also create a trend just by moving my hands. Alright, now I can go back and traverse up the tree by pointing to the left. So let's do that, and we can do it again. First we have to go back to the natural stance, and then we can traverse up and again, and I can traverse down again, enter the element, go to the bottom attribute and create a trend just by moving my hands. Traverse down, create a trend, and go up again. Enter this element, go down, enter the element, go down, and create another trend. And we can go all the way back, and this is the top one, and we can enter the logistics one. We can go down, and we can enter, and we can create a trend with this value. And we'll go back again, and if I put my hands up again, it will stop accepting commands. So let's do that, and now I can move, put my right hand down or my right hand up without affecting the traversal. If I put both hands up again, I can go down and enter, go down, enter, go down, enter, and create a trend. If I put my hands up again, it will stop accepting commands and I can move pretty freely. Alright, this was a short demo on the Kinect SDK and the Kinect sensor, and how we can use it to traverse a PyAF tree. I think there are a lot of other options for in the future. I'm not really sure on how practical this will be, but I think there are a lot of possibilities, including augmented reality and presenting or manipulating trends or elements. So that's something we have to look for, and we have to I think start making stuff and start developing, because I think there are a lot of possibilities here. So thank you all for watching, and I have to say this sensor costs about 100 euros, and I think it's one of the best 100 euros I ever spent. There are really a lot of possibilities using a device like this. So thank you all, and if you have any comments or questions, just leave them on the vCampus forum or in the blog post, and I hope I can show you something more later on. Thank you very much.